minimum time to visit a cell in a grid. So let me first explain the problem. After that, I'm gonna try to use the shortest path to solve the problem. So we are just getting a grid. Inside the grid, there will be numbers. And we want to calculate the destination, the distance from this top left corner to the bottom right corner. So for example, this is 0. It will go from the top left to the bottom right. But it needs to meet the conditions. And let's check the conditions. So let me check where is the conditions. So the top left, it is the 0th second. So the second is just the time. And each move just takes 1 second. While we are solving this problem, we should also check the time. Because at the beginning the time is 0. If it moves 1 step, the time will plus 1. For example, at 0, 1 position, the time will be 1. So let me check. So inside it will consist of non-negative integers. It will be 0 and positive integers, and the grid row and column represent the minimum time. So this is very important. The minimum time, as you can see, the black minimum. The minimum time required to be able to visit the cell, which means you can visit the cell only one. It's a lot of things, but it makes confusion. Maybe it's just 1 sentence is enough, but it makes 2 sentences. Sometimes it will be confusing, which means you can visit the cell, row and column only when the time you visit it is greater than or equal to. What does this mean? This means while you are visiting a cell, for example this one, the grid R and C, the grid row and column, it is 1, must be more than, let me check. It must be more than and equal to, it means the time must be more than and equal to the grid row and column. So this means grid row and column must be less than and equal to the time. Now let's check the example. At the 0, it's gonna be 0, 0. At 1, it will go to 0, 1. Because it is possible. Because the grid should be less than and equal to. So while t equals to 2, it will be moved to 1, 1, move to this position. So let's check t equal to 3. While t equal to 3, it will move to cell 1 and 2. So it will move to 1 and 2. It will move to 1 and 2 here. It will move to this position. And now let's check t equal to 4. It will move to 1, 1. It will go back. Why? Because it cannot go to this position. Because if it needs to go to this position, the time limit is 5. But currently, your time is only 4, because here 1, 2, 3, and when it moves to this position, the time is 4. But currently here is 5. It means what you need to do. You cannot go to this position, but you can go back and go forward until you meet the conditions. The time is more than and equal to this 5. Let's check. So currently T4, the grid R and C less than and equal to 4. When it goes to 5, grid 1 and 2, it is 5. 5 is less than and equal to 5. It means you go back and forward, and then you go to this position, and then go to 6. While you go to 6, the time you consumed is 7. So you're gonna return 7. So this is basically a Dijkstra's algorithm. The difficult part is about the time. But after you solving the time, actually you can solve the problem. If there's no time, it is just a Dijkstra's algorithm. You just check the shortest path. But with the time limit, you need to consider. So for example, at this position, you cannot go to the 5. Because the time is not enough. So you have to wait. But you cannot stay at position. You have to go back and forward until your time is enough to go to this position, until the time is more than and equal to 5 when you go to this position. So how should you solve it? Let me first draw an example. Because this is a Dijkstra with mathematical problems. Without drawing, you cannot understand. Yeah, the Dijkstra's algorithm is easy to understand, yeah, and easy to do. But for the mathematical calculation, we need to consider. So, for example, I'm gonna use this example to represent some predictions. So, for example, here, yeah. So, yeah, I'm gonna use similar examples. So, for example, here, this value is yeah. Let me make a odd value. This is even. Let me make an even value. So the even value is 6. But what is the result for this node and this node? It can be 0 or 2. It must also be even. Why? Because, for example, this is 0 and 0. This is 0 and 1. This is 1 and 0. So the row and column, the sum of row and column for this one, it must be even. Yeah, if it is just starting, if it is just looks like this, it can have other grade like that. Yeah, but for this one, it must be an even value. And this one, if it were to go to this position, it must also be an even value. So for example, at this position it is a 0, or maybe at this position it is a 0. If you want to go to this position, you can go here and go down. You can go down and go here. So it can be a 2, but it must be an even value. If you want to go to this position, you still need to go here and go down. Go down and go right. Yeah, it's also, you need 2 steps. It's also an even value. It may be 4 or maybe 6, right? Yeah. It means the time. If this is even and the time you consumed from the starting point 0 to this position, it must also be even. Yeah. So if it is even, what are you gonna check? You just need to take this value as the maximum distance. Yeah. So for example, this is a 5 at this position. 5 plus 1, it is a 6. And this may be also 5. Yeah. Or this may be 4 or maybe 3. 3 plus 1, it is a 4, and this is a 6. But you need this is a 6, you're gonna take the maximum value. Because until it is the maximum value, you can reach this position. Otherwise, you cannot reach it. So you're gonna take the maximum value with this one and this one. So if it is always even. But what if this value is 6? It is instead of 6, it is 5. It is just a odd value. Yeah. But the best solution, if you were to go from this node, the first node 0, go from this corner 0 to this position, it must be an even value. But here it is odd. But how should you solve it? Yeah. So for example, here, for example, this is 4, and this must be even. This is 5, or this may be 3. Yeah. So for example, this is a 5. You need to go. If you want to, yeah, it is a, yeah. If it is a 5, if you want to go down, it must be 6. So the 6 is more than 5. It must be an even value. Yeah, because here is 5. If you want to have a value more than and equal to 5, it must be like 4 and 6. So you're gonna choose 6. It can never be 5. Yeah, it's like you are going from here, you go from here. It can never be 5. This is like while you are going in a grid. So for example, this is 0, this is 2, and you go to here. This gonna be 3. 3 is not enough. You go here, it is 4. You go back, it is still 5. Yeah, if this is 5, when you go to here, it must be 6. It must be an even value when you go to this place. It can never be an odd value. Yeah, maybe you think, why? Why not? Let me take this value be even. And then I'll go here, I'm gonna have an odd value of 5. Yeah, because I want to have a 5, but that is not possible. Because, for example, this is a 0, and if you want to go to this place, it must be even. And if this is an even value, for example, it is 4, 2, or other even values, if you want to go to the neighboring values, it must be 1 step, or 3 steps, or odd steps. but it can never be two-step. So it is a 2 plus 1, it can be 3. Yeah, or 4 plus 1, it can be 5. But this value can never be 4. Yeah, so this means while you go to this prison, this must be an odd value, and here must be an even value. Yeah, but you want to take a value more than and equal to 6. Yeah, so what are you gonna do? So if the result, yeah, if the result for the time, if the time t is 6, it is just okay. Yeah. So what if the time is yeah, if the time is 6 and the grade row and column, yeah, so the grade row and column is also 6, it is okay. But what if the grade row and column it is 5? Yeah. So if this is a 5, and here you need to prepare a 6. But how can you prepare a 6? You just need to use this value 6, yeah, minus the row and column. The row and column, it must be an odd value. Yeah, the row and column must be an even value. So if it is an even value, you need to minus a 0. So if the row and column, row plus column, it is an odd value, you need to it should be plus. You need to plus 1 for the final result. Yeah, let me just start coding, and if we comes across this kind of math calculations, I'm gonna go back to explain it. Yeah. So let me just start coding. I'm gonna use the Dijkstra algorithm. So I'm gonna prepare a row and column. It's gonna be the length of the grid and the length of the grid 0. I'm gonna prepare the distance array. So the distance array would be infinite times r and times c. I'm gonna write it like a 1D array because I think this gonna save me some time. Basically it's the same. So the dist 0 gonna be 0, and I'm gonna prepare a priority queue. So inside it's gonna have the distance x and y positions, row and column positions. I'm gonna have to check. So if this position at the top left corner, if I can go to right and go down, so this value must at least have a value of 1. If this is 5 more than 1, and if this value is also more than 1, it means I can never go to the next step. I can never go to this position, and I can never go to this position. So I'm gonna return a -1 immediately. So if grade 0, 1 more than 1 and grade 1, 0, yeah, I'm gonna check its neighbors. So I'm gonna return a -1 because that is not possible. Yeah, I cannot even go to this one and this one. It is not possible. I'm gonna return a -1 immediately. If I can go to this prison, definitely I can go to the bottom right corner. Because if I can go to this prison, even my time is not enough, but I can go back and forward, just to do the repetition like this, back and forward, until the time is enough, and then I can go to these prisons and go to the bottom right corner. Yeah. Now I'm going to check this priority queue. So I'm gonna pop out the distance row and column. Would be hip pop with PQ. I also need a directions array. Let me prepare a directions array. It just be 4 directions: 0, 1, 0, -1, and 1, 0, and -1, 0. So yeah, I'm going to check if r equal to r -1 and c equal to capital C -1. It means I can go to the corner, go to the bottom right corner. I'm gonna return the distance. So otherwise, I'm gonna check the directions. For DRDC in directions, I'm gonna prepare the row and column. It should be r plus dr and C plus DC. Now I'm going to check the row and column if it is inside the boundary. Yeah, if row inside the boundary and column inside the boundary, it should be less than or equal column less than C. It means inside the boundary. Yeah, if it is inside the boundary, I'm gonna check the distance. Currently, the distance is just D. It is popped out. It is 0 because from the beginning. Now, my distance, I'm gonna prepare a new distance. I cannot use D equal to something like maximum of D plus 1 and yeah, let me check. It will be distance array. So the distance array, I'm gonna prepare a current variable. So this current variable would be equal to row times column plus column. So this is just 1D array and 2D array. You can also use 2D array, but I prefer to use a 1D array for the distance array. You can see here. If I put it in a 1D array, so here similarly for the 2D array, I need to turn it into 1D array. So this is my current, and I'm gonna take the I'm sorry, it's not the distance. It's gonna be the grid row and column. Yeah, it's not the distance because I'm going to check the maximum. Yeah, if it were to go to the next grid, the distance should plus 1, and the grid should be row and column, should be this value. Yeah, but I'm gonna take the maximum of the value. But this D is not finished yet. We have to check. Do we need to plus 1? Yeah, if it is okay, for example, this is a 5, but for this position, for example, this is a 0, 1, 2, 3, 4. Normally this is gonna be even value, but here is odd. So if it is odd, even it go back and forward, we need to check. Yeah. So here we cannot use the distance because here we already have a variable of D, and we're gonna use this variable D each of the time inside the for loop. So here I'm gonna use another distance maybe. Yeah, I'm gonna use a distance should be maximum of D plus 1, and the grid row and column. So this distance should be updated according to the math formula. So it's gonna be the distance. Yeah, so it's gonna be the distance minus row and minus column divided modulo 2. So this is depending the row plus the column. If the distance is even and the row plus column is also even. So for example, let me go back to the drawing. Yeah. So let me prepare a new drawing. Maybe it's easy to explain by this drawing. Yeah. So if this is odd, so for example, this is a 6, and maybe here this is a 4. So currently this grid row and column it is a 6, but my time this distance this distance is dependent on the maximum of D plus 1 and the grid row column. Definitely it's gonna take the maximum value. Yeah, so for example, even here the distance maybe just 2, but I'm gonna take 6. Otherwise, yeah, if I just use a BFS or Dijkstra's algorithm, I have to go back and forward. It's gonna have an infinite loop or time limited. So I can just make a shortcut to calculate it, use a mathematical formula to calculate it. Yeah, if it is 2, so for example, my time is 2 to this person, but this row and column, grid row and column is 6. It means I can directly take this 6. Why? Because even this is 2, I can go back and forward, how many times? So this is 2, 3, 4, 5, and 6. Yeah, it is just like that because currently it is 2. If I go up, it is 3, go down, it is 4, go up 5, go down, it is 6. So it means I don't need to do anything. So what if this is just 5 and my value is 2? So for example, I need to go up, go down, it is 4, go up, it is 5. But I need to be at this position. So I have to be 6 because it must be more than or equal to 5. Yeah. So this is why I used this formula. The distance should be minus row and column modulo 2. Yeah, this is exactly to check if row and column, row plus column is odd, the distance should also be odd. Yeah, if there always be the odd minus odd value, 3 minus 1, it is even modulo 2, so it is 0. If there always be even, row plus column is even, distance is even, so modulo 2, it is also a 0. But if one of them is odd, another is even. So for example, the distance as I explained is odd, and row plus column is just even. So we're gonna have this result will be a 1 because the distance needed to plus this value. So here I'm gonna use a plus. Now we're gonna update the distance. We're gonna update the Dijkstra array. So let me check. Yeah, so if distance, if our current distance is less than the distance array of this current, so this current is calculated because I turn it into a 1D array. So I'm gonna update the distance Dijkstra array. So the Dijkstra current should be equal to distance. Yeah, this is exactly the Dijkstra's algorithm at this part. Yeah, even though we have the time, but we already converted this time to distance by using the formulas. Up to here, this is the first step. This one gonna be easy because we always take the maximum value, but this one gonna be a little bit hard. Especially it is inside a grid, we have to use some mathematical formula to check the distance. We need to check, do we need to plus 1 or do we need to plus 0? It is always dependent on the distance minus row plus column. Yeah, let me put a row plus column. Maybe this is also easy to understand. Yeah, because row plus column should be a whole part. Yeah, it always depended on the row plus column and the distance. If they always be even, we're gonna plus 0. If one of them even, another is odd, so we're gonna plus a 1. Now the distance array is updated, so I'm gonna hit push inside the PQ. Yeah, I need to push the distance, row, and column. I think this is the entire code. I'm not sure. Let me just check it. So this is the distance, and here is updated. Yeah, let's just have a check if it works. Grid is not defined. Oh, I made a mistake, a typo. Yeah. Let me try again. Yeah, now as you can see, it works. Now let me just submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases and it's pretty fast. Now let's analyze the time complexity. Yeah, because we used the mathematical formula to avoid so many calculations go forward and backward because that will be time limited. Yeah, you can check my submissions. I also have the time limited issue and the wrong answers issue. Yeah, let me just open one of them to check the time limited issue. Yeah, you can see from the beginning if I just didn't use this mathematical formula, I didn't find the formula, I just use some t plus 1, it means I go forward and backward and it will be time limited. As you can see here, I prepare a t plus 1, each step it will be t plus 1. Of course, it will be time limited, yeah, because this time will be a very big number. Yeah, so we have to use this kind of a formula to check the maximum value. Here the distance would be the maximum, and the distance should plus 0 or 1. It is dependent on the positions and row plus column. Yeah, positions of the grid. Yeah, and this value, the grid row and R, this value, and the positions of this value. Yeah, for analyzing the time complexity, it would be easy. So m and n is just 1000. So the time complexity is m times n log m times n, because for the Dijkstra's algorithm, the time complexity is e log v. E is the number of edges, so the number of edges will be just 1000 times 1000. Yeah, and yeah, the number of vertices is also 1000 times 1000. So, but it is m times n log m times n. Even though m times n is a big number, but log m times n would be a very small number. So that is why it can pass. Yeah. Thank you for watching. See you next time.